Assalamu alaikum dear students. Bismillahir Rahmanir Rahim. Welcome you in a new lecture that is related with the design, the analysis of an overhang beam, and this is in this beam basically we will analyze uh, the beam for a moment which is applied just at the hinge support, and there is a varying uniformly distributed load, okay, as you see. So as this is an overhang beam, so we have two supports, one is two spans, one is this one and one is this one. Clear? Basically here I am trying to explain a different option that is related with the grid spacing. Okay, so I am not basically selecting the beam template. Clear? So make sure units will be in Kip's sheet, and now this is your template window. So cap feet, and I'm selecting this options right now. Clear? This is, you can say, a new option. Okay, and we will using now this option that what grid only this template, through this template how we will develop or how we can develop a section. Clear? So here you will select a Cartesian as well as a cylindrical. Okay, so we will select a Cartesian. Okay, not we will basically deal with cylindrical. We will deal with the Cartesian grid system. Clear? Now you will see there the number of grid lines. Okay, so the number of grid lines in X direction, Y direction and Z direction. What does it mean? You have three coordinate system. Clear? You know that this is your Y, this is your Z, and this is your X coordinate system. Clear? So basically this is mean that it will develop a kind of rectangle. Okay, this template or grid spacing is basically developing a kind of rectangle. Clear? For example, if I have this rectangular block, so the length of this block is basically representing the x-axis. The width of this block is basically representing the y-axis, the length x-axis, and the depth of this system of this box is representing by y-axis or z-axis. Sorry. So this is z-axis. Now basically if you want to understand this grid line system, so x direction, y direction and z direction, this means that how much grid lines you have in x direction and in y direction. Okay, so you need to define your number of x-axis. For example, for this system, for this beam section, for this beam, you have, if you want to compare this beam with this box, okay, and you want to look at this beam into this box, you need to first of all find out the x-axis, y-axis and z-axis. So let's say this first hinge is basically representing the x1. This is x1, and this is representing x2. Okay, and this overhang portion is basically representing x3. So basically, to look at this beam within this box, you need 3 x-axis. Okay, you need 3 axes. One this one will be there somewhere there. Okay, that is your 2, and that will be your 3. Now, as this is 2D section, it is not a 3D section. Okay, so therefore it has only one z-axis. Okay, one z-axis. So you can either give them z-axis 2 or 1. Okay, let's say we will look at it in a 2D. So you have, this is z-axis 1, z-axis 1 and z-axis 2. Okay, and if let's say I assume a full box, and I assume that this is this is my y1 and this is my y2. Clear? So in x-axis I have 3 axes, and in y-axis I have 2 axes, and z-axis I have 2 axes. So therefore I write there, in x direction I have 3, in y direction I have 2, and in z direction I have 2. Clear? Now I have to define now grid spacing. The grid spacing is basically mean that how much distance is in between these x1 and x2 and x2 and x3. Okay, so we give one value because this value and this value is different for this beam. This is 6. From x1 to x2 this is 12, but from x2 to x3 it is 6. Okay, so we will edit this spacing in ladder. Clear? So we will just put only one spacing, and let's say that is 12. So grid spacing 12. Okay, in y direction, okay, here I don't need to put the spacing in y direction. Okay, this is y direction, that how much this y2 and y1, that how much distance is in between y2 and y1. There I will suppose that, let's say, the distance in between y1 and y2 is 1 feet, and let's say the distance in between z1 and z2 is 1 feet. Clear? And ignore this one. Okay, ignore this and okay. So this is the system which you seen. Okay, this is the system. Clear? And these are the grid lines. Clear? This is A, B. If you want to look this system in XZ plane, so this is the XZ plane. Clear? From A to B and from B to C. This is the overhang portion, and this is the middle portion. This portion. This is A, B, and C. Clear? So now you will see that. Okay, now you will see that this is your grid lines. Clear? So in 3D you see that this is your 3D view. Clear? So you must understand this spacing. It is very, very important. In later stages you will see that how you will use this spacing. Clear? So if, let's say, I will this is, now I want to explain this grid line. Okay, I want to spend a little bit time on this spacing because it is very important. In later lectures, inshallah, you will see that how we will use this okay, because it is very important to understand. This is your x1, okay, this is your x2, okay, and this is your x3. Clear? The distances in between these two grids, this is 12, and in between these two, this is 12. Clear? And I have to adjust the spacing with reference to, with reference to this example. Clear? I have to adjust the distance in between x1 and x2 is 12 feet, and x2 and x3 will be 6 feet. So I have to adjust this, okay? And this line and this line, basically this is y1 and this is y2. So the distance in between y1 and y2, we don't need these distances because we are dealing with a 2D object, okay? So in later stages, once we will dealing with the 3D space, okay, or 3D objects, so we will need these distances. For example, if you are designing a room or a hall, anything, so that is a 3D object, that is a 3D object like this. Clear? Let's say this one. So you have to insert now the distances in between x, okay, this will be the distance in between x, which representing the length of a room, and then you have to insert the height of this object, and height, let's say, that will representing z, and then you have to insert the width of the room. Clear? That will be your y-axis, okay? So in later stages you will see, okay? So if we are assuming that we are developing a room, so we have number of grids in x direction, that is 1, 2. Number of axes in y direction, we have 1 and 2, and number of axes in z direction, we have 1 and 2. And then we will insert the spacing, that we have the distances are spacing between grid lines x1 and x2. This is my x1 and this is my x2. I will insert the length of the room, and the distances or the spacings in between y1, this is my y1 and this is my y2. Clear? That distance is this will be representing the width of the room, and I will insert that value, and the distances in between z1 and z2, okay, I will insert the height of the room. So in later stages, once we are analyzing the 3D frames, so we need this kind of spacing, okay? So there I will assume the distance in between y1 and y2, and I put that distance, let's say this is 1 feet. Clear? And then we have other two axes, that is this at this level and at this level, that is your z1, z2, and this is z1. And I also assume the distance in between, because I don't need the depth of column, okay, the depth of beam, okay. I just assume that, let's say it is 1 feet, okay. So this is a kind of explanation of these grid line spacing, you must understand, okay. Now we will define, we will make them according to the beam which is given to us. Clear? Because we have an overhang portion, and that overhang portion, basically AB, this is 12 feet, and BC, this is 6 feet. So I have to adjust this overhang to 6, and this AB portion equals to 12 feet. Clear? So make sure that you will be in XZ plane. Clear? So here I have to edit these grid lines, okay. So let's say edit grid data, modify and show system. Now the same window which I already edit, okay, this window. Now you need spacing, clear, and keep foot, and there the distance in between AB, that is 12 feet, I think you people understand it, okay? And the distance in between BC is equals to 6 feet. Clear? And I don't need to edit this Y grid data and Z grid data because I don't need. But in later stages when we are dealing with 3D objects, so we will edit these grid lines as well. Clear? So for the time being, just leave this as it is. Clear? Okay. You see the picture right there. A to B is 12 feet and from B to C is 6 feet right now. Okay. And okay. Now this is the spacing. You can check it. The origin point of the coordinates are now at this point. So from this point your B point lies a distance of 12 feet. So you can see there. Okay. You can see there. This is 12 feet. And this is at a distance of 18 feet. So this means the distance in between this point B and point C is 6 feet. Clear? Now I have to draw the beam. Okay. There I am drawing the beam manually. Okay. So to draw the beam you have to use these options. Clear? You have to use these two options. Okay. Draw, frame or cable. And this is a quick draw and frame. What's the difference? Let's see. Once you select this line, okay, in later stages inshallah we will define this is a beam through this and this we drawing the columns and beams of a structure. Okay. At this stage you just know that how we will draw a beam and a beam. Okay. But in later stages means once I am designing, okay, the beam columns, okay, so first of all we need to define those sections. Okay, there it basically it asking for that whether you are line object type. What is your line object type? Whether it is beam, it is column, it is cable, whatever. There it asking for section. What section, whether you are what type of section, because we will define, okay, our sections in later stages once we are going towards designing. So you will see that we will design, let's say, a rectangular section, so we will define their width and we will define their depth. Okay. So and we name that section. Let's say we name this section as S12 by 18. So that S12 by 18 section will be right there. You select them and draw them. Okay. Here you can see moment releases. So we don't concern with these things right now. Clear? So you just need to, you know, click this option and just start drawing. You click this point, then click at this point and then click at this point. Now you will develop two beams. Okay. You can use this option. Let's say use it. Control Z, Control Z. The difference in between these two, this is quick. How it works? You just need to only click this line and you just need to only click this line. Clear? So your beam will be drawing. But there is a difference. Although they both work same, but there are some time we need, we use this first option because it is a little bit useful in some occasions than this one. So at this moment I don't explain that reason. Okay, so you just need to understand that how we will draw a beam or a column. Okay, so this is the way that how we will draw a beam and a column. Clear? These are the area sections. Through these we will define the slabs. Okay, slabs. So in later lectures, in coming lectures, I will use these area sections as well. Clear? So for the time being you just know about that how we will define. Okay, now I'm going to define you the joints. Okay, so here at this joint I need a hinge support. Clear? The rest of steps are same. Okay. Basically I need to define joints at this point A. Clear? So there is hinge, so select hinge and OK. This is your hinge support, and this at this point I need basically a joint that is a ruler support. Clear? So this is a kind of editing of your beam. Okay, so through grid spacing. Clear? And by using your grid lines. Clear? So now I have to assign the loadings. So at joint A I have a moment which is about y axis. Okay, so that is 1500 pound feet. Okay, pound feet. So you need to select. Okay, now units are different. Clear? Units are different, so you must cautious about the units. Clear? So the load is basically assigned to this beam. Clear? So let's see frame loads, and this is point. Clear? You need to make it 0 self-weight multiplier. Okay, and modify. Okay, okay. Oh shit, sorry. Assign frame loads and point loads. Clear? So let's see, check it. 0 0. Okay, you need to pound feet. Clear? Pound feet, because the moment is in the units of 1500 pound feet. You select moment. You need to apply moment about y-axis, add to existing loads, and absolute distance, and at distance 0 you have a moment of 1500 pounds feet. Clear? And OK. So the moment is now assigned to a structure right there, and that is in this direction. So basically this means that it is in a clockwise direction. Clear? Make sure x-plane, and there you need to assign uniformly varying load. Clear? And that load is basically 3 kf per feet at 0, and a 6 feet it becomes or equals to 0. So let's see, I have a force, the units are kfs, feet, add with existing, and the direction is gravity, absolute, and at distance 0 I have intensity of 3 kip, and at distance 6 basically I have intensity 0. So okay, so this is now your assigning uploading. You just need in a position of analyzing right now the structure. Do not run now, and you need to saving the structure. Let's say this is my example number 1. Okay, so let's see our first of all our reactions. So this one is 1625, and this one, sorry, this is 15 kf put, this is applied, this reaction I think so it is 1625 kf, and this is 10 point, this is 16.25 I think so, and this is 10.625. okay, so let's see, I think so it is 1.625. clear? So you need to press this button, join, and OK. So this is 1.63, this is 10.63. okay, this is confirmed. Now your shear force diagram will be in this way. Clear? So let's see, press this button, frames, and there you will select shear 22, show values, and OK. So 9 and 1.63. clear? And now we will check the moments. You see that is minus 18 and 1.5. So let's see, press this button, frame, and moment about 3.3. Let's say 18 and 1.50. So I think the work is done. the work is accurate, and we complete the job, okay, or we complete the task accurately. Okay, we will get an accurate diagram of shear, accurate diagram of bending movement, and accurate reactions. So this is the procedure, I define you a new way of defining the structure, okay, because in later stages we use this grid spacing, okay. So you at a lower level, at a very small level, I define you that how we will use this grid spacing. Inshallah, in coming lecture you will see I will use this grid spacing more in a more explained way, in more a detailed way, So I just give a very short picture of those grid line spacing. Clear? So if you have any question, any doubts, you can contact me. Watch the videos and enjoy. Thank you.